After capturing our design in the schematic, we can now look at the improvements of Altium Designer 18 in the PCB environment. In this section, we will see how we can define the board options, interactively route with the assist of the enhanced active route, while making use of the properties and view configuration panels throughout the process. Initially, we will perform a design transfer from the schematic to the PCB environment through the design menu list. Upon executing the ECO, we will see that the components and nets are brought into the PCB. Like in the schematic environment, the properties panel in the PCB environment is also content specific, and it allows users to view and edit properties of multiple selected objects. When nothing is selected, the properties panel will show board information and allow configuration of snap options, grids and guides, and units. We will ensure that we turn on the snap to grid option and set the default units to mils. Now that we have the board settings configured correctly, we can start placing the components and route them. At this stage, we can make use of active route in conjunction with the interactive routing. Initially, we would route the important nets through the interactive routing, which is accessible from either the route menu or the active bar. We can then define the corresponding length and match length rules. We will set a length rule of between 5000 mil to 7000 mil, and a match length rule of 50 mils. In this example case, we will set these rules to target all nets on the board, but for most cases, length rules would only target the crucial, high-speed nets. Following this, we would interactively tune the nets that have been routed. Using visual color indicators in the PCB panel, we can ensure that these nets are of the necessary length, abiding by the rules defined earlier. We will then select the remaining nets we wish to route through active route by holding the Alt key as we draw a rectangular select of the rat's nest. Within the active route panel, we can first define the actions we would like to enable. In this case, we will enable gloss results to ensure that we have cleaner routes with less unnecessary steps along the way. We can then ensure to set the layer which we would like to allow for routes. If no layers are selected, it will only utilize the active layer. We can also define the control settings such as track-to-track spacing control and meander in terms of percentage over Manhattan length. We can then define the route guide to ensure that the routes created by the active route are within this guide. Note that the default route guide width is dependent on the track-to-track spacing defined, as well as the clearance rules. However, when drawing the route guide, designers can make use of the up or down keyboard navigational keys to increase or decrease the guide width. Once we have defined the active layer, the route control, and route guide, we can then simply hit the active route button to route these nets to the defined settings. Since we have match length rules defined earlier, we will now look at how in Altium Designer 18, active route can be performed while adhering to match length rules. We will undo the previous route command and reselect the rat's nest. This time around, we will enable the Tune Selected checkbox within the active route panel. We will also ensure to check on the match length rules we would like to enable. Lastly, we will define the accordion shape settings used during the length tuning process, where we will decrease the minimum space to 15 mils. Once we have defined the length tuning settings, we can then simply hit the active route button to route the selected nets. This time around, instead of just abiding by the layer and track control settings, the routes will also adhere to the length tuning settings as well. In addition to this, Active Route could also perform pin swapping during its route. This is enabled by checking on the pin swap routing checkbox, where it will then reduce the number of net crossovers through an iterative process. We will now look at the example SL1 project, where we would like to make edits to its board layout. First, we would like to ensure that the vias beneath the chip U1 to be of a specific size. To facilitate our selection, we can make use of the pre-selection filter, which can be accessed through either the Properties panel when nothing is selected, or through the active bar. Once we have applied the pre-selection filter for vias, we can then select the objects of interest by drawing a selection rectangle around the area. We will then notice that only vias will be selected, despite other objects within the selected area because of our pre-selection filter. In the Properties panel, we can then set the hole size and diameter of the selected vias to 0.5 mm and 0.8 mm respectively. Like in the schematic editor, if we have objects of multiple kinds selected, we can make use of the post-selection filter to control properties of which object kinds to show. Similarly, this post-selection filter is accessible from the drop-down beside the filter icon in the Properties panel. For example, we would like to now modify the tracks and vias of the ground net. We will first reset our pre-selection filter to all objects. We can then make use of the PCB panel to select for ground objects. Prior to this, we will ensure that the Select and Clear Existing checkboxes are checked. Once we select the ground net in this panel, all objects assigned to this net will be selected. The Properties panel will then show properties common to all selected objects, which include paths, vias, tracks, and regions. Once again, we will make use of the post-selection filter accessible from the drop-down beside the filter icon. By setting it to filter for tracks only, we will show only properties for selected tracks in this panel. We can then modify the track width of the selected ground net in here. We can subsequently change this filter to vias only and modify the hole size and diameter of the selected ground vias. To improve designers' efficiency during layout, the View Configuration Modeless panel can be used to actively toggle layer visibility, change layer sets, and add mechanical layers. Under the View Options tab, we can also configure single layer mode options and PCB object visibility. Additional options such as net color override can also be actively controlled from this panel. In this module, we discussed on the improvements of Altium Designer 18 in the PCB environment. In the next module, we will see how components part information can be transferred to the procurement team through the enhanced active bill of material.